Okay, my friends, I'm back for Unit 2, video lesson number 5 on atomic mass. Now, this is the last video for Chapter 4, but not the last video for Unit 2. Right now, we know that the number of protons and the number of neutrons contribute to the mass of the atom. Now, protons and neutrons are particles, so you can't have a partial particle. So, if carbon has 6 protons and 6 neutrons, then you would think that the atomic mass of carbon would be 12. But if you look at the periodic table, and I have a partial part of a periodic table here, you'll notice that the atomic masses are not whole numbers. They are decimal numbers. So the question is why? And that's what we're going to learn about in this video. Each element has at least 2 naturally occurring isotopes. Thus, the atomic mass takes into the account the masses of each of the isotopes. So, for instance, look at this. We have 4 chlorine atoms, and here you have an atomic number of protons is 17, 17, 17, and 17, and then the number of neutrons that we have is 18, 18, 18, and 20. And so if we add up the number of protons and the number of neutrons and then divide by 4 for each of the 4 atoms, we get a weighted average of 35.5. So why is it different than what's on the periodic table? If we looked at the periodic table, we would see that the atomic mass for chlorine is actually 35.453. So why here is it a little bit larger? Well, here's what happens. The isotopes of an element are not naturally present in equal quantities. So you have to consider their relative abundance. The relative abundance is the percentage that they exist in nature. So let's consider this problem. The element copper has 2 natural isotopes. You have copper 63, and it has a mass of 62.93. AMU is atomic mass unit, and a relative abundance of 69.2%. So in nature, we would have 69.2% of the copper would exist as copper 63. That's what that means. The other isotope is copper 65. It has a mass of 64.93 AMU, or atomic mass units, and its relative abundance is 30.8%. So in nature, 30.8% of the copper exists as copper 65. Now we want to determine the atomic mass, and here's how we do it. You're going to take the mass of one of the isotopes, multiplied by its relative abundance, add it to the mass of the second isotope multiplied by its relative abundance, and you'll keep doing this for each one of the isotopes that exist for that particular element. Since copper only has 2, we're just going to add the 2 together. Okay, very simple. So we're going to take the mass of copper 63, multiply it by its relative abundance, and use a decimal percent. And how do you do that? You have to divide by 100. So 62.93 times 0.692. And we're going to add that to the mass of copper 65, 64.93, and this should be multiplied by its relative abundance, 0.308. And we add those together, and we get that the atomic mass unit for copper 63 is 63.5 AMU, atomic mass unit. And that's how you calculate an weighted average atomic mass for any element on the periodic table. So I keep referring to AMU. What is it? Well, an AMU is a unit that is assigned to the atomic mass of an atom. It's based on the mass of a carbon-12 atom. It's being used as the standard. The masses of protons and neutrons are extremely small, so instead of working with those really small numbers, scientists agreed to use the carbon-12 as a standard and assigned its mass as exactly 12 atomic mass units. So all of the other elements are kind of based off of that carbon-12 atom. So the atomic mass unit then is defined as 1/12 the mass of a carbon-12 atom. Okay, and that is the end of Unit 2, video lesson number 5, and that concludes Chapter 4 in our textbook. This is Mrs. Weethy, so long for now.